Okay. At least you get a little tour of FlowHub. So that's not the button I want. And we are not on localhost. Double check, report, yes.
Need to switch network again or not?
Yes, but I can do this first. That's a good point. Okay, now I have that. Yes.
Yeah.
Now, where is the shit?
Sorry, my browser doesn't support it. I disactivated JavaScript.
Okay, we are connected. So, that's a good start.
Okay, if you need help, I'm there.
Things here look alright. Is my sound okay? Yes, so about the setup, since I'm doing demo, there is some IoT devices here, just dev board, ESP8266, another one, Node MCU, so same chip. They're just connected to battery, and they're all on Wi-Fi. It's using my phone as a hotspot, kind of bridging it, because this is actually a nice portable way. Then you don't have to like reconfigure your devices. Just it works for a kind of personal work. And we're using MQTT to communicate. The broker in MQTT, which those things are talking to, is running on my laptop. Normally that would be your IoT gateway, could be a Raspberry Pi, could be a router, whatever. And then on my kind of developer machine, in this case is this one, which is very unfamiliar to me with the ASCII keyboard and stuff. We have kind of our development environment. So this is actually a little bit good that we had to do this switcheroo, because it's showing now that I'm on a different device doing the UI parts than the actual runtime. This is the normal case when you're in the deployment. You're not going to have a full IDE and this kind of stuff on your Raspberry Pi or whatever. You might not have a screen and so on. So I'm connected over WebSocket to that stuff. Okay. So I hope we will have some devices. Yes. I have two devices, and they just have a couple of different things. I have one attached to the relay on it. That's the red board right here, and it actually has a LED also on the relay. So it's called LED, the input, and because we're communicating over MQTT, I need to configure this to have a known name, relay, and this one is buttons, like that. And right now the devices are not doing anything. They're just sitting there. They're publishing. I can see here, I can see that they are saying hello, I'm here, and this kind of stuff. Yes. So what should be possible now is I can, for instance, take the button here and connect it to the relay itself. So now that I'm clicking the button, this thing is actually kind of talking to itself over MQTT. Okay, there's something. Maybe you have a light which is actually hardwired. You know, okay. However, maybe not the most generally useful thing. So maybe our device is somewhere else. You know. So now I just have LED to show. Now it's connected to this thing. So we can live rewire the system in order to change connections. This could be like setting up the initial thing, or it could be like just changing how you like things. Like, I don't really like that I have to go to that device to trigger that thing, or this kind of things. So that's changing connections. We can also add more components. So classical stuff that happens now all the time is incompatibility of devices. And then you need like, okay, take this JSON thing and take us message and then make it work. Or you want to have some functionality. A lot of the ideas which I will go through is about like avoid fixed functionality in your system. Build devices that do something, sensors and actuators, and then build the system together in a flexible way. For instance, using a tool like this, using Flow, because this has a lot of benefits. So, for instance, I think we have a really simple component. Actually, let's add it from okay, I'm not going to live code. I had a sample code, but it's on that machine. So it's really, but I actually have the component. So normally you could go here, create a new component, and write your code. I'll show you even if I'm not using that one. Invert, we'll just call it 2. We support a bunch of different languages, and it's really easy to add more with Msgflo. CoffeeScript and JavaScript are good. Also C++, Python, anything like that. So it's nice to, that's the wrong key. And then you get a nice little editor where you can do that. It means when you create a component, actually we can instantiate it. So I have done this before, and I have okay, it's not showing here. I hope it still works. So for instance, I have this invert component. Just plug it in between here. And now the light is on when I'm not pressing it, and off when I am pressing it. So this is just super simple. I mean, of course, you can have as complicated stuff as you want. You have a full programming language, or many programming languages, Python, JavaScript, and so on. So this is also nice because it always happens. Even if you have this system that's kind of designed to work together, there's always a little, it doesn't really. And that's like it's a very pragmatic solution to this incompatibility. We don't try to make the universal way of doing things, like just, okay, that stuff doesn't work this way, this stuff works this way, build something to plug it together. And we have some testing tools, also automated testing, that uses the message queues, so you can can have good faith that it actually will work. Let's see for time. Okay, I'll do a little bit more demo. Let's add, I have this timer component. I have a toggle component, and in general in Msgflo, the participant shouldn't do much when they are, so now nothing happens, but if I specify an interval, 100 milliseconds, now we have this blinking light, whatever. So that's actually a stateful component. You know, it remembers, okay, we were off before, now we need to go on, and so on. And you can do this as well. So this could be complicated stuff like talking to a database, finding what this message should mean, and doing it live, talking to the internet or some service, and so on. But yeah. And also this shows that we can change the configuration data, right? So for instance, when you're working with user experience, it's sometimes hard to predict what's the right values of things, you know, like maybe this is kind of 1 second showing activity but not stressing people. So you can kind of explore your way to find out maybe 1200 is the right word. It's just showing that you can do live things there. And yes, that's it for demo. And since I've been so demo focused, my slides are not even up. Yes, and we are, as I said, we're talking, it's all MQTT. I will, oh, I am on the wrong network, wrong internet. Happens all the time. I try you one. Yes, and so this is where you find the source code for Msgflo. We also have a new website now, msgflo.org. I put my slides here because that's nice. I hope there is a PDF reader. Chrome is my PDF reader. Okay. So yes, so the typical way you do MQTT communication, you're sending on some topics, and they have names, and depending on the both on the send and receive, and then your system can't do anything else. So instead, what we do, so you have a system that can only do basically one thing, and you can't see how is it working, where is it sending stuff? It's all digged into the code. Using Flow, you can see it easily, and how it works, we send. For instance, we send the button sends on button something, not directly to the motor or the light, because this way it kind of has its own namespace, and then something else like FlowHub, or you can use a hard-coded list of queue mappings or whatever, connects them together, and this gives you the flexibility to reorganize it. And with Msgflo you can do it live, which is nice. In addition, we send a discovery message. So we send information, each device sends information how and describing itself, like what is the component. This is kind of like, so I can have many of the same components. They are each in a different role. So one can be a light button, one there is a motor button, one is so this is reflecting their purpose, but it's not hard-coded, so you can still like rewire. And then it says something about its ports. So like this is a kind of data flow, flow-based programming model for how to do the queues. So the MQTT queue is actually this thing here. So that's how it, on the wire, it's communicating. And then, yeah, you can use this little FPP DSL to connect things together. Here I'm connecting the pressed state of a imaginary button to a start of a motor. And the motor could say when it's running, there's a, say to another lamp that makes it red, the warning, so that you know that's potentially dangerous and so on. You can use this tool to set it up. So that's kind of how you would, like, that's without the live and visual programming part. And, but what about devices that don't talk Msgflo? As long as you talk MQTT or AMQP, which we also support, you can kind of declare this information about how it works separately in a YAML file, and then you can have this tool send it on behalf of the device. So this is a way to have your existing MQTT things appear and be connectable in this way. Of course, sometimes they are hard-coded. They're sending, then there's not much you can do. Then there's an incentive to maybe change that code and make it. And yeah, as I said, we can do live programming, as I demonstrated. Then you run Msgflo with your initial graph, so like what's the basic stuff. You open your browser. As I said, this computer I've never touched before. We just load the browser and connect to the right IP address, then you can do it. And the nice thing is all the connection information is in a URL. So we're saying, okay, please open the IDE, app4.io, and please IDE connect on WebSocket to this address. So you can actually have a QR code or NFC token where you go bloop, and it comes up directly on your tablet, your laptop, or whatever. So that's nice. Of course, you just need to send this discovery message to make stuff work with Msgflo and talk MQTT. But there are also these convenience libraries which you can use, which make it nice and easy. We have JavaScript and Node.js, NoFlow, it's another visual programming environment, a visual programming runtime that FlowHub can use. C++, Python, Arduino. I'm using the Arduino here. I use Python in the example, and one other example was JavaScript. We have a Rust one, which currently only supports AMQP. So that's yes. So for the current status is that the programming model, we've actually been using this a lot, like how this is set up together in on backend services for cloud systems, and there we're using AMQP, and that's really well tested. We're running millions of jobs every week through the system, and it works really well. We're primarily using the JavaScript and NoFlow libraries. That's really battle tested and works well. MQTT we haven't used so much yet, so it's a little bit rougher. We have some small deployments in hackerspaces, so of MQTT with Msgflo in Seabase in Berlin and Bitraf in Oslo. So like you can use it for stuff. Live programming, like a demo now, is not so much tested, but it's also not part of the the core production system. We stay out of there as much as we can. So it's not, maybe the developer doesn't have the best experience, but the system works. MQTT SSL support, the Msgflo, is actually not tested. This is one thing that might cause you to want to wait a little bit to do a real deployment, because you need SSL to securely do authentication on Mosquito, for instance. Yes, future. So right now on MQTT, Mosquito, which is the most common broker, and in the protocol it's not no routing is specified. So when we use Rabbit on MQP, we actually ask Rabbit to say, okay, connect this thing to that thing. So we are staying out of the kind of core communication path. However, on MQTT, there is no standard for this. So we have our own, it's actually running in our own process. And we would like to kind of get rid of that. So we want to support RabbitMQ routing, also MQTT, because they support that. And then the code that we currently have will probably separate out as its own kind of like really well-tested router for MQTT, so that if you run Msgflo, which doesn't have this functionality, you can plug this in and it can work. Yeah, there are some changes we want to do more with how we visualize data in FlowHub, so you can kind of see the data flowing through. There's a PR for this open right now, which would give you like at least a text stream of messages coming through, which is very nice, because a lot of times, documentation is slightly wrong. It says it sends on this format, but actually it's not, and it's really nice to be able to see that directly. And then, but one of the big things we want to do is we want to take this programming model, which works now for connecting stuff together. We actually have a microcontroller runtime, which you can program live, like the logic internally on the device, and we'd like to expose this, so you can have this big network of this device talks to that device, based on like, oh, how does that device actually work, or has a bug, whatever. You go in to that node, and then you see the network inside, and you can change it. So that's the big things. And also, we have a couple of tiny changes we would like to do to the protocol before we call it Msgflo 1.0, because that would be a stability point. So we would like to get some minor fixes, actually just renaming the queue and some small conventions. So yes, that's it. Questions?
Just what's the front end of FlowHub there?
That's
Repeat the question.
yes. What's the front end? That's FlowHub. It's an open source IDE. It's running completely in the browser. So that's why it works when I'm not on the internet and this kind of stuff. And it's also offline capable. So you find that that's under FlowHub/NoFlowUI is actually the code. It should be renamed, but you find that there. And you can use that to target other things. The microcontrollers. You can do sound programming with it, image processing with it, and stuff like this. So that's yeah. Go.
Do you support MicroPython on the ESP, or how do you?
No. Well, it's like if you would send that discovery message, that little JSON thing.
Could you repeat the question?
Sorry, if we support MicroPython on the ESP, we don't. But if you would use the existing MQTT support in MicroPython and just send that JSON, it will work.
Yes, you said that communication encryption has not been tested, SSL has not been tested.
Yes.
Has it been implemented and not tested, or is it something that...
The question was, SSL has not been tested. Is it implemented and not tested, or like not being started? We are using existing libraries for MQTT support. So they have SSL support, both in Node.js and Python and so on. So we're using PAHO and Python and so on. So like, base stuff is there, but it could be that we our small conventions trip something later up. So I think it's literally like a couple of hours on each place making sure it works and documenting.
Thanks.
Other questions? Again?
Have you looked at, on the SSL topic, have you looked at Curve 25519, which is way slower and way lighter than SSL? I mean, on the ESP there is no support for HTTPS, as far as I tried. And but there are libraries for Curve 25519, which can provide encryption in a lighter way, especially for those light CPU devices. So on ZeroMQ, for example, they use Curve and tiny tweet and SAL by default, which makes tweet and SAL for the libraries. I've seen some for Arduino.
Yeah.
So, if you want encryption, I think either you try to get the job done by external libraries, or you might look at Curve to do...
Yeah, so the comment is have you looked at Curve as an alternative to SSL encryption. For communicating on MQTT, we're kind of relying on what the broker supports, otherwise they can't talk together. And as far as I know, Msgflo only supports TLS 1.0, so probably that will be limitation. There's also the end-to-end encryption, which is also, I think, quite interesting. It's a separate topic. That is very nice, because then you can send through an untrusted network. So it's not about making your network secure. It's about sending securely over an unsecure network. And there definitely something like Curve and these designed for embedded encryption is very, very interesting. And Msgflo actually doesn't care about the payload that you send between, because we have a slight preference for JSON, but you can send buffers of arbitrary stuff. So that means you can do this without changing any of the code. So.
Okay, let's take other questions outside.
Yes.
Thanks a lot for the presentation, and
yeah.
give a big hand.